It has been quite an evolution in the modern data center. So what we saw in the early part of the hyperscale era, or maybe traditional computing, is there were SMP systems, large-scale systems, shared multiprocessing. You tried to build large nodes so that you had very efficient cost models and also very high performance. Then the next layer was embarrassingly parallel applications that were put on commodity systems. So now instead of having one or two large nodes, we had fleets of 10, 50, 100 nodes. But very targeted at very specific applications, embarrassingly parallel. Then the next generation, over the following 10 years, many more applications were moved to this hyperscale or scale-out model. And that happened by rewriting application stacks, rethinking architectures. So now many more applications could be applied in a 1,000 node, 5,000 node, 10,000 node cluster of distributed systems. There's also quite an investment in distributed system technology, software stacks, as well as some hardware stacks to enable that hyperscale evolution. And the good news is now we're at an era where modern applications are being explicitly designed for those environments. So now that we've built out the environments, we have a large fraction of applications that are already deployed at hyperscale. New solutions, new scenarios are being designed with hyperscale in mind, which means they're natively hyperscale or cloud native in some incantations. And ultimately, the benefit to the customer base today is 30 and sometimes 40 years of innovation in computing at large scale. By bringing hyperscale technology to the broader market, we're allowing customers to benefit from 10 years, in some cases 20 years, of innovation across the industry in the service of hyperscale. So the types of optimizations that were possible when service providers are running fleets of thousands and tens of thousands of nodes, that enables optimizations and simplifications that are not possible if you're designing for 10 and 20 nodes. But since we now have the benefit of more than 10 years of hyperscale optimization, we're able to take the best learnings and apply those to smaller workloads and smaller customers. So the real benefit is that there has been 10, sometimes 15 years of innovation in large-scale computing, and that's allowed us to see what are the good ideas, what are the not as good ideas, and we can take the best ideas and bring them available in a smaller form factor, smaller footprints, smaller investment horizons. What we're doing with Sesame is we're building on over 15 years of hyperscale innovation done by companies across the industry. So many of the largest service providers, participating with the largest technology vendors, some of the most innovative companies doing software-defined storage, software-defined networking, CPU technology, memory technology, storage technology, all of that folded together for large-scale clusters, rack-level build-outs, and supporting all of the world's most demanding workloads.